up, guys? In today's video we're going to be looking at piston rings and ring gap. So I'm going to start the video off with a just a quick introduction. I think it'll be interesting for you to see that we're going to be looking at two different rings, a used set of rings, and then also I've got a brand new set of standard rings. Again, standard bore for the Chrysler 400, and then we're going to use those as sort of a comparison tool, compare and contrast the difference in the ring gap, and then I'll walk you through how to actually take the ring gap and just sort of share other observations as we go along. So without further ado, here we go. This is our used ring out of our donor engine, and this is our new ring that's a standard bore ring. So if you recall, we talked about the ring. We have to sort of compress this when we push it, force it inside the cylinder. And of course, part of the ring's job is, the primary purpose of the ring's job is to stop compression gases from passing by between the piston and the cylinder wall, right? It helps seal that gap. So again, so the reason this gap is important too, and why we need a feeler gauge to check it, is because I think thermal expansion is the technical term. Basically, when it gets hot, we know that when metal gets hot, it expands, right? So you want this gap to be as close as it can be, but still leaving enough room so that when it gets hot, when this metal expands, it doesn't sort of cave into itself, right? You can imagine if there was only maybe 1/1000th of an inch there, and then as the metal, as you start the engine up, as it starts to warm up, I'm going to over exaggerate this, but let's say this is the gap. As it heats up, it's closing, it's closing, it's closing, and then it starts to actually collapse in on itself. You can imagine bad things are going to happen, right? You've got this piston that this ring sits in this ridge, and then as it gets hot and it starts to collapse in on itself, just chaos is going to ensue, right? So the idea is we want this gap as close as it can be, so it can have the maximum amount of compression in the combustion chamber, but leaving enough room for thermal expansion, right? So when it gets hot, it doesn't sort of smash into itself. Generally, your race engines, I think this gap is a little larger because you're going to be dealing with higher heat, and it can be a little closer on a street, on a street engine. But the last measurement I wanted to show is, again, let's look at our stock ring. And what I wanted to look at is the ring width. So this measurement here. And so again, it makes sense, right? Is this, so this is our worn ring, that as these begin to wear out, this had the wider gap. The reason that is because the outer edge of this is worn down as it's rubbed against the cylinder wall. So I'm going to use my dial caliper here, and I'm going to take a measurement of the thickness. Again, do it like that. So I'm doing a thickness here between these two, and they say technically to use the machined edges. I actually like to use those flat edges of the caliper, and I've got about 195 thousandths there. Let's see if I can show that. If I close that up, so you can see it there, it's about 195 thousandths. Whereas this one is, well, that one's about the same. Why is that? Okay, that was about 200 thousandths. Let me go back and measure here again, because I thought there was about a 10 thousandths difference in them. Okay, so this one's actually about 192, 193 thousandths. This is Yeah, 198, right at 200 thousandths. All right, so there's about a 10 thousandths difference there. And again, the reason that is because these worn rings, the outer edge has sort of worn down over time as they begin to wear. This is kind of an interesting. This would be an interesting comparison to show you. I've actually got the set of rings that I pulled out of my donor engine, and we're going to put these in here. And what I want to do is show you the difference in a set of worn rings as opposed to. I've also got a brand new. Now this is a brand new standard bore ring, and we're going to look at the difference in the gap between these two, and you'll see it's pretty stark. Okay, when you're doing this test, you need to make sure this is completely flat, or at least pretty flat. So what you're looking for is it can't be sort of cattywampus in there. It needs to be turned to. It needs to be 100% straight. So the way to do that is to take a piston. Now this piston doesn't have any rings in it, so you can take this piston and then slide her down in there. And I'm going to go down to about right there. And then I'll do the same thing here. So that makes it fairly straight. So, all the way across here, it's down in there and it's nice and straight. You also don't, generally the diameter may be a little, you have what's called a ring ridge at the top. So generally you want to push it on down in there at least an inch or two, I'd say. And the other thing you can do is, again, depending on how sophisticated you want to be with this, you can take multiple measurements, one sort of at the top, one in the middle, one down all the way down at the bottom. Again, depends on sort of what you're doing. Again, if you're building a 7,000 RPM race engine, you probably want to take 3 different settings because you want to make sure it's right. Okay, so the first thing we'll do is look at the difference in the gap on these. Alright, so I've got, here are my 2 rings, and I think you can see, hopefully you can see this gap down in here, and where I'm looking at is right here. If you can see the difference in that gap, and then this gap over here. Now again, what you're looking at here is a brand new ring. Now this is a brand new standard bore ring, so it's for the 400, for the Chrysler 400, that's going to be 4 inches, 342 thousandths. So you can see the difference in that gap, and then this gap here, how much bigger. Now this is a worn set. The donor engine that I had, I pulled these rings out of there, so that gives you a sense. So what's happening here? How did that gap end up being bigger? Well, as this ring rides against the cylinder wall here, as this ring rides against the cylinder wall, goes up and down, how many thousands of times every time the engine's being ran, the outer diameter of that ring wears out and it wears down. And as the outer diameter wears out, that's going to increase this gap, right? If you think about it again as a sort of circle like that, and as the outer diameter wears, it's going to continue to press against the cylinder wall, so that gap is going to get larger. So all engines, the pistons on all engines have a specification for what that gap, and actually they'll give you a range for what the gap should be. Now again, you can see, let's see if I can pick this up. Yeah, I can't quite get it on here. This is 25 thousandths. Yeah, you can't see it. It's stamped on there, but this is a 25 thousandths feeler here, and even for the standard set of rings, that's way too loose. And in fact, I think I added a couple other feeler gauges, and this is probably closer to 27 or 28 thousandths. So that tells you how much wear is on these cylinders. Not a crazy amount, but and again, I haven't decided how I'm going to address that yet, but I think I've got a couple of ways to go. And part of the theme of this video series and just the work that I do in general is what's the right way to do the wrong thing. Now, the right thing would be to have these cylinders bored out over one size over maybe 30 thousandths, and then you also buy oversized pistons, oversized rings, but that's a lot of money, and I don't want to spend that kind of money. And I'm just curious. In my experience, in building other engines in the past, you can get pretty good service out of an engine, even though the parts are out of spec. Now, not grossly out of spec, but even if there's a lot of wear there, you can often compensate for that by either oversized rings, or probably what I'm going to end up doing is what's called cut to fit rings. And basically that is, it's just a set of oversized rings, and then I'm going to actually grind them down so they've got the proper gap. Now we're going to look at the other factor is we're going to look at cylinder piston to cylinder wall clearance, and so that'll give us more information, right? So there's a bunch of different data points when you're building an engine like this. And especially what I'm trying to do, where I'm taking a donor engine using used worn parts and then putting them in another block. I mean, there's a bunch of different data points, and so part of these measurements, all the measurements that you're going to see here, are just, again, a way for me to get different data points and make an informed decision about the components that I use, and whether I have machine work done or not, or whether I need to buy new pistons, and whether I, so all of those decisions are going to base not just on one piece of information, but a collection of information. So anyway, that is a cylinder ring gap and how we gauge it. Okay.